Have you ever wondered how calculators actually calculate? It's easy to say that 1 plus 1 equals 2, but how do you teach a calculator to figure that out? Moreover, how do you teach a calculator to figure out the ratio between the opposite and hypotenuse of a triangle? It's not like it has an extremely precise ruler in there that it could just use to measure out the different sides of a triangle. Well, it all comes down to really thinking about connecting things from math to things that are out here in the real world. See, calculators have these things called transistors, which are basically like switches, like a light switch that you would use to turn on the lights in a room. It's just that these switches can be activated through electric current, making them useful for automation. Now let's think about all the different combinations that two different switches can have. There are 4 in total, but let's see if we can draw any parallels between these switches and actual numbers. In what way could we express on or off in terms of digits? Well, one way that might come to mind is with the use of the digits 1 and 0. 1 represents the switch being on and 0 represents the switch being off. So let's use this convention to convert all of these different combinations into this digital form. See, now we can essentially express all of these different combinations of the two switches being on or off with the use of this convenient notation. Now let's see what happens when we add even more switches, see 2 more. Here are all the different combinations that these switches can have, and here are their representations using our newly invented binary system. This seems awfully similar to our familiar base 10 system for counting. In fact, if we just let each of these positions correspond to 2 to the power of the position, we can essentially use this system to count from 0 to 15. Now if we have n switches or transistors, we can use them to count from 0 to 2 to the n minus 1. So that's how calculators and computers count, but how do they perform arithmetical operations? Well, to add these numbers together, it's actually pretty simple. What you do is you just align each digit from one number to each digit of the other number and add up the digits. If the two digits are both a 1, you can just count that as a 1 in the next position. If you want to subtract 1 from a 0, you just write the answer as a 1 and subtract by 1 from the previous position. If you want to multiply, you just do repeated addition. And if you want to divide, you just do repeated subtraction until you get to 0 or until you can't subtract anymore without the number going negative. And if you're dealing with non-integer numbers, you just move the decimal point and treat the number in the same way as before. Okay, but what about things like trigonometric functions? Well, to figure that out, we use the tools of calculus. In calculus, there's something known as the Taylor series. It is basically something that can convert any function to an infinite polynomial. Well, technically speaking, it doesn't work for any function. The function must be what's known as analytic. We don't need to know exactly what that means though. Just keep in mind that it doesn't work for all functions. With that being said, it does work for all the functions that you're most likely familiar with, which means we can drop higher order terms in its Taylor expansion, since we can't do this infinitely, and approximate things like sine, cosine, tangent, exponential functions, and logarithms. And since polynomials only use the 4 arithmetical operations that we are familiar with, we can teach calculators precisely how to compute the different values of these functions. So that's a basic way of explaining what's going on under the hood of your calculator whenever you use it to compute something.